Okay, so part D just gives us a couple of different things to look at here. First one is to find the volume and the surface area of a hemisphere. That's no big deal. So let's do the volume first. So the volume of this hemisphere, we've talked about this a number of times. Instead of being 4/3 pi r cubed, since we just want a hemisphere, it's going to be 2/3 pi r cubed. And we're given that the radius is 15, so all I have to do is plug in 15 for r. Get my handy dandy calculator going here. 15 cubed is 3,375, and I'm going to divide that by 3 and multiply it by 2 and come up with a final volume of 2,250 pi cubic centimeters. And so that has a pi in it, so that would be your exact answer. If I want an approximate answer, I take that and multiply it by pi, and that would be 7,068.6 cubic centimeters if that's how you want to do it. Okay, to find the surface area of this hemisphere, including the base, this is kind of a fun one. We know the surface area of a sphere is 4 pi r squared, so that means the surface area of a hemisphere is 2 pi r squared, but then we have to add on to that the area of the circular base, which is another pi r squared. So it turns out to find the surface area of this shape here, if I want to include the circular base, it's a simple formula, 3 pi r squared. And this is especially easy because they tell us the radius. We don't have to do any work to figure that out. So 15 squared is 225. And 225 times 3 is 675. So the surface area of that turns out to be 675 pi square centimeters. And once again, that is the exact answer. So if for some reason you want to multiply that out and get an approximation, it would be about 2,120.6 square centimeters. All right, next one, then we need to find the volume of this composite figure. This means we're going to have to find the volume of the cone that's on top, and add on to that the volume of the cylinder that's on the bottom. So the volume formula for a cone is 1/3 the area of the base times the height. In this case, well, in every case, since it's a cone, it means the radius of this is 3.5. So to find the area of the base, I need to go pi times 3.5 squared, because it is a circle. And then to find the height of this cone, I have to say, well, the height of the cylinder is 13. The height of the entire shape is 22. So 13 minus 22 leaves me 9 for the height of the cone itself. So I'm plugging 9 into there. And I'm just going to go ahead and slam this out on a calculator. So I'm going to go pi times 3.5 squared times 9 divided by 3, which is 115.0, around 4.5-ish. We're doing volume there, so that's cubic centimeters. That's an approximate answer, I guess. If you wanted to do that in terms of pi, it would have come out to be an exact answer of 36.75 pi cubic centimeters, but either one of those is fine. Okay, now we need to add on to that the volume of the cylinder, which is, the formula for that is pi r squared h. And so we know everything we need to know to figure that out. The radius of the cylinder is 3.5 centimeters. The height of the cylinder is 13. And so if I keep the pi in my answer, 3.5 squared times 13 is 159.25 pi cubic centimeters. And then I need to add that on to the volume of the cone that I figured out before, 36.75. So that comes out to be, oh, that's pretty nice, 196 pi cubic centimeters for my total volume final answer, which, if I want that as a decimal, that's approximately 615.8 cubic centimeters. Either one will do. Okay, and then our last problem for this is the old ice cream cone problem. We have a scoop of ice cream. It happens to be a perfect sphere with a diameter of 6 centimeters. So our ice cream is a sphere with a diameter of 6 centimeters. It is placed in an ice cream cone with a diameter of 5 centimeters and a height of 10. So, if for some foolish reason, instead of eating your ice cream, you let the whole thing melt, would it all fit in the cone or not? And so what they're asking us to do here is to compare the volume of the scoop of ice cream with the volume of the cone to see which one is bigger. Well, to find the volume of a sphere, we of course need to use the formula 4/3 pi times the radius cubed. Since the diameter is 6, the radius is half of that, or 3. And so if I multiply that out, that gives me a volume of 36 pi cubic centimeters. I don't know if that's a lot of ice cream or not, but that's just how that works out. Now to find the volume of the cone, I have to go the area of the base, which would be pi r squared, times the height. The radius of the cone is only 2.5 square centimeters, and so if I multiply that out, it's 2.5 squared times 10 works out to be 62.5 pi for a volume. So the answer is, if for some foolish reason you want to let all your ice cream melt and drink it instead of eating it, you got plenty of room in the cone for that, because the volume of the cone is way bigger than the volume of the ice cream. Assuming I did that right. Okay? Alright, so that's the end of the practice test answers. So we will have our test tomorrow. Good luck.